Okay, well, the last couple of class periods we've been looking at how forces are applied to objects, and we last Wednesday looked at force comparisons, and we defined Newton's third law of motion, which says uh, anytime two objects interact with one another, they exert forces that are equal in magnitude but opposite in direction on each other. As we get into analyzing motion further and how forces are applied and cause changes to motion on objects, we need to learn how to diagram the forces acting on objects. So that's what this video is going to be about today. On Friday, we did the book on a table demo activity, and we defined a force called the normal force. So we're going to analyze the other forces acting on the book on the table today. So that's why I've got my little drawing here of the book on the table. Interaction diagrams. Interaction diagrams are used to show all the different objects, surfaces, things that are involved in a potential force diagram, so that we can look at the different objects, what things are interacting, what forces are being applied to the different objects, and then we can define our system so that we can do a force diagram for further analysis. So, interaction diagram. What we need to look at is what are the things that are involved in this scenario. And so for the interaction diagram, we begin by listing everything that's present. So we have the book. There's also the table. We also have something else that's involved in the situation, and as we get into analyzing things, one of the forces that we need to make sure we account for in all of these problems is the force of gravity. The force of gravity is caused by an object's interaction with the Earth. Okay, there's different types of forces. One type of force is a contact force. A contact force occurs when you have two objects that are in physical contact with one another. But there's also long range forces. Long range forces are forces that are exerted between objects that are not in physical contact. So for instance, the force of gravity acts on us whether we're standing on the surface of the earth or not. I mean, if you've ever fallen off of something, you know that the force of gravity is acting on you as you fall. So another object that is involved in our system here is going to be the earth. So we've got the book, we've got the table, and we've got the earth. What we need to do is start looking at then what things are interacting together. Well, we see that the book is sitting on the table, and we analyzed that. And so we know that there's an interaction between the book and the table. There's also an interaction between the book and the earth, and there's interaction between the table and the earth as well. Now, as we look at these interactions between the book, the table, and the earth, the interaction that takes place between the book and the earth, that would be the force of gravity, which is F sub g. When we start labeling forces in diagrams, big F stands for force, and then we use a subscript to signify different forces that might be acting on it, different definitions of forces. We also have the force of gravity acting between the table and the earth. Okay. And then we also have the book that's sitting on the table, so we have an interaction there as well. Okay. All right. Let's see, do we have any other interactions that are taking place? We have the book on the table, we have the book to the earth, we have the table for the earth. No, I think that looks pretty good. So we've got some options here. What is it that we want to ultimately create a force diagram for? Well, I think for our book on the table scenario, we will do a force diagram for the book. So as we start to diagram the book, we want to simplify down our picture and kind of separate the objects that are involved in our diagram. So typically what we do then is we will replace our illustrated picture of what is going on, and we will replace whatever the object is that we're analyzing with just a dot. Okay, so we're going to do a force diagram for the book. So this dot is here to represent the center of mass for our object. And we'll just make a little square around it so that we know we're talking about this block, or about the book. Now, according to our interaction diagram here, if we look at the book, there's forces on it because of the table, and there's forces on it because of its interaction with the Earth. So if we look at this, we can start with probably the most obvious one, which is the force of gravity acting on the book. The force of gravity that acts on an object is always going to pull it down towards the center of the Earth. So we'll begin by putting a downward arrow indicating the direction of that force. The force on our book is the force of gravity. And then we have one other thing that we want to include for our force diagram, which is what we call on-by notation. On-by notation is a means of taking what we have for our interaction diagram and then translating that over to our force diagram. What on-by notation means is what is the force acting on, and what is the force being caused by. Okay. So on-by notation. So here we have our book, force of gravity is acting on it. Well, for our on-by notation, the force of gravity in this case is on the book, and it's being caused by its interaction with the Earth. So we had the force of gravity on the book by the Earth. For on-by notation, the force, or the on part of our on-by notation, should always be the object that we are analyzing the forces on. So if we have a force that we end up putting on our force diagram for the book that is not being put on the book, then it doesn't belong there. Okay. From our discussion on Friday, we also know that because of the fact that the book is interacting with the table, that the table is causing a force on the book. And we define that one in class on Friday as the normal force. Okay. Anytime we have an object sitting on the surface of something, it is going to have a force that is acting on it that is perpendicular to that surface. So in this case, we have the normal force that is on the book, and it's being caused by the table. Okay. So we have the force of gravity pulling down on the book by the Earth. We have the force normal that's acting on the book by the table. If we compare our force diagram to our interaction diagram, in the interaction diagram we had two forces acting on the book because of its interaction with the table and because of the book's interaction with the Earth. we have those two interactions in our interaction diagram, and then when we translate that over here to our force diagram, there's also only two forces. That's why we do the interaction diagram. It allows us to utilize the ideas from Newton's third law, where the forces acting on or between two objects that are interacting would be equal in size but opposite in direction. So we do the interaction diagram to look at all the interactions between all the objects involved in the situation that we're analyzing. We choose the one object that we want to analyze, and then we can take those interactions and translate it to a force diagram. Okay, so that is our first example. We are going to have one more example. I'm going to pause the video for a second so that we can have another example to look at. All right, here we are with the next example. This is actually question 1 from your homework assignment for tomorrow. So we'll do this one together, and then you'll be on your own for the rest of the assignment. On this assignment, for each of these scenarios, you need to create an interaction diagram of the situation, and then do a force diagram for both blocks A and B. We're going to do the interaction diagram for this, and then we'll do the force diagrams for both as well. So to begin with, let's take a look at the situation that's going on here. We have two blocks, blocks A, block B. They have different masses. They are being pushed by the mysterious floating hand. They're being pushed to the left, and we see here that we have a constant velocity in that direction. So it is being pushed, the blocks are sliding, and they're sliding at a constant velocity. All right, well, let's take a look first of all at what things are involved in the situation for our interaction diagram. We have our two blocks, so we'll have block A, we'll have block B. We also have the Earth as a part of it, because again, the Earth is going to be causing gravity to act on them. We also have another thing involved here, and that is the surface or the ground. Okay, the blocks are sitting on the surface. Okay, we need to have that separate from the Earth because the surface itself is not causing gravity on these blocks, but rather the Earth as a whole is what causes the gravity on the blocks. So we have a separate interaction between the blocks and the surface or the ground than we do with the Earth itself. All right, so as far as, oh, forgot, we also have the hand. The hand is a part of this as well. Glad I thought of that. Okay, so what is interacting? Well, we have the hand that is interacting with block A. We have block A interacting with block B because they are in contact with one another. We have an interaction between block A and the ground. There's an interaction between block B and the ground. There's also an interaction between block A and the Earth, and block B and the Earth. I guess we could also take a look at then the interaction with the hand and the Earth, because the hand is there. The hand must exist in order for it to push the blocks, and so the Earth would have an attraction on that as well. Okay. As far as an interaction between the surface and the ground, we'll leave those separate. I mean, technically, the ground itself is a part of the Earth, but like I said before, the Earth as a whole is what causes the force of gravity acting on blocks A and B in the hand. There's separate interactions for the surface and the ground, which we'll talk about here in a moment. Okay, well, let's start with the force diagram then for block B. So we'll have our square like so. And let's look at what is acting on it. First of all, we'll deal with the interaction with the Earth itself. That would be a force of gravity on block B by the Earth. Now you'll notice that I'm using little shorthand notations this time instead of writing it all out. You can do that if you want to. Otherwise, as you're practicing, if you want to continue using the full written out words, that's also suggestible. Okay, what else do we have? We have the interaction between blocks A and B. But what's happening here? Block A is pushing block B to the left. So the force that A puts on B would be in that direction. So we have a force on block B by block A to the left. And then as far as the interaction with the surface, we know from our book on a table activity that we're going to have this normal force acting on it. And that's going to be on block B, and it's going to be caused by the ground, so I'll put a G for that. And so if we look at our interaction diagram, there are 3 interactions acting on block B. We've got 3 forces in our force diagram, but we are not finished. We need to look at the fact that this thing is moving at a constant velocity. Now, one of the things that we're going to get into is how do these forces affect motion? And for right now, I'll just throw this out there for you. If something is moving at a constant velocity, it has to have balanced forces acting on it. By balanced forces, that means that all the forces, if we added them up acting on a block, have to come out to 0. So right now, if we look at the force of gravity and the normal force, they are in opposite directions to one another. And if they were to balance each other out, they would have to be the same magnitude. In order for the force on block B by block A to be balanced out by something, there would have to be another force acting in the other direction. So what is that force? Well, as you have probably experienced in your lifetime, if you interact with a surface, let's say you're running or sliding across the surface, there is another interaction that takes place between the surface and the ground, which is called the force of friction. So we also have the force of friction on block B by the ground. The force of friction is defined as a force that opposes motion. Well, from our picture, we know that the motion is going to the left, so the force of friction, if there is friction acting on block B, would have to be going to the right. Okay. So just remember, if we have constant velocity, therefore no acceleration, forces are balanced. Okay, so if we compared the magnitude of these, then they would come out like so. So there's our force diagram for block B. We have the force of gravity on block B by the Earth. We have the normal force on block B by the ground. We have the force on block B by block A as it's pushing against it. And then we have the force of friction acting on block B by the ground, causing it to move at a constant velocity. Okay. So we would also do the force diagram for A, and we're going to do that quickly here, and then we'll be all done, and you'll have the rest of the time to work on your own. So I'm going to erase all this so I have room to work here. We can look at our interaction diagram. So block A. What do we have acting on it? We have the force of gravity acting on block A by the earth. We have the hand, force on block A by the hand. We have the normal force acting on block A by the ground. And then once again, we have to have a force of friction on here. And so we have the force of friction on block A by the ground. But that's not the only force acting on it. There is another one, and it is a part of, we need to include in our interaction diagram here, that second interaction for the force of friction. But we also have the force of block B pushing back on block A, this one right here. Okay. So we need to include that into our diagram. We would not have a second arrow pointing back to the right, but rather we would add it to our diagram, force on block A by block B. So to the right on block A, we actually have two forces. We have the force of block B pushing back on it, and we also have the force of friction acting on it. And those two forces combined are balancing out the push by the hand, just like the normal force and the force of gravity are also going to be balancing each other out. If you also compare the force diagram for block B to block A, you'll notice in this one, the force on block A by block B is to the right. And if you look at your force diagram for block B, the force on block B by block A was to the left. Again, showing that for the interactions, the forces exchanged between them are not only equal in magnitude, but they would also be opposite in direction. Okay, that's it. That's your tutorial on these. So for class tomorrow, you need to do an interaction diagram for each of these examples, and then do force diagrams for both blocks A and B. We will be whiteboarding them and discussing those results for probably 2 days would be my guess, because we have a lot of different examples to look at. So that's it. Go ahead, you have the rest of the time to work and have those ready for class time tomorrow.